Hello my friends, thanks for watching and welcome to my new video. In this video I'll be talking about Python. I'll be talking about the basics that you need to get started with Python. In my previous videos I talked about how to install this Anaconda navigator, and I also talked about these two main editors, that's Jupyter and Spider. And in this video I'll be using Jupyter to illustrate the different things that you need to get started with Python in machine learning and also in data science in general. So let's get started. So I'll start with variables. So in Python, variables are just objects. It's very easy to declare variables. You just have to say, for example, x is equal to 1. That will mean x, whenever there is x, that will be equal to 1. And then you can start using it in calculations and in your code. So there are different kind of variables. We have like integers, strings, and real numbers. So you realize for strings, we added these quotations here. They are very important to declare something as a string. And this is how you affect them. So I also added this other part here in the bottom. So this is mainly used in loops. For example, the for loops. When you have let's say x that changes every loop, it changes maybe from 1, then it increases to 2, it increases to 3. How would you do this? You can just do it by saying x is equal to x plus 1, which looks a bit weird, but that's how this program was written. And another way of doing it is by just saying x plus equals to 1. So each time you run the loop, x will increase by 1. So to declare a variable, it's very easy. You just have to say x is equal to 1. Then you run the code, and if you try to print x, we get 1. So that's how you declare x. And if you want to say the type of x, you can say x dot type. Okay, that's not working. It's supposed to be the other way around. Type x. So we can see that x is an integer. And you can simply just say, if you want to replace 1 by something else, let's say a string, let's say x is equal to boys, you can just write it. You don't have to declare anything. And when you try to print x this time, it gives boys. And when we try to look at the type of x, this time it's going to be a string. Okay, that's it for variables. In arithmetics, there are different things we can do. We can do additions, we can do subtractions, we can do multiplications, we can do all sorts of mathematics. There is actually a library that's called math that you can import and do all sorts of calculations. So here I'll also show you an example in Jupyter. So let's say we have two variables, x and y. X is equal to 2 and y is equal to 4. Okay, we can do addition, so that's x plus y. I made a mistake. It's supposed to be small y because Python is case sensitive. So if you're using small letters, you're supposed to stick to small letters, and if you're using to upper cases, this will be read differently. Okay, so we can do, we've seen that's addition, subtraction. Now we can do multiplication, we can do division. Okay, that's basically it. All right, so we have seen arithmetics. Let's go back and look at something else. Okay, now we are going to look at comparisons. In comparisons, we have less than, greater than, less than or equal to, greater than or equal to left-hand side, equivalent to the right-hand side. So we use this double equal signs, and we use this to declare that something is different from the other. So what Python will return is a boolean, which is true or false. So in case you say the x is greater than y, it will either return true or false depending on the validity of the expression that you've written. Let's try to do something here. Okay, so here we've already declared x is equal to 2 and y is equal to 4. So we can say, for example, that x is less than y, which is true. And also we can try something which is false. Let's say x is greater than y. And this returns a Boolean false because x is equal to 2, which is not greater than y. Or let's say x is equal to y. This is false because x is equal to 2 and y is equal to 4. Okay, that's it for comparison. Now for logics, as you can see, I didn't really add a lot of stuff because normally you can just write and or of. You don't really need to use these symbols. You can just write the word and the code. For example, if you wanted to say and, you just write it like that, and or like that. Like Python will understand this, so you don't need to use symbols for this. Okay, next part. So in the next part, I'll be looking at the functions. So here we are looking at functions. So functions can be declared by simply using the word lambda. So to do this, you just have to write f is equal to lambda. Then you declare the variable, which is x in this case. You put two dots and write the equation. So this is equivalent to f of x is equal to x squared. We can go ahead and write this in our code and see how it works. Okay, you just have to say f is equal to lambda. Then here you declare, you leave some space, you declare the variable. Let's say x, and you, after the two dots, you put the equation that you want. X is equal to 2 squared. So this function has been accepted without any errors. So to recall the function, we just have to say f of, let's say 2, which is weird because okay, all right. So to declare the function, you just say f is equal to lambda x, two dots, then you add the equation. So I wanted to say x to the power of 2. So you put two multiplication signs, then add 2. And you can also declare several, you can declare a function with several variables such as x and y by simply repeating the same thing and separating the two variables with a comma. Then you just basically repeat exactly the same thing that you did. Let's say x squared plus y. And now if you try to say, let's say y is equal to 10 and x is equal to 2. It's the other way around. It's y is equal to 2, x is equal to 2 and y is equal to 10. And we get 14, which is 2 squared plus 10, which is 14. So from functions, let's look at functionality. So we have what we call functions in Python. You can create a function. And there is also something else that we call classes. So I'm not going to be talking about classes. It's a bit complex, but I'll just talk about functions briefly. Let's talk about functionality. So in Python, we have what we call functions that are defined by the user. So to declare your own function, you begin by using this expression, which is def. So you put the name of the function, the variables, the calculations that go within, then you return either whatever you want to return from your function. So here I wanted to calculate pressure, and we know pressure is equal to high times density times gravity, and here we return pressure. So we can go ahead and run this. So I wanted to run a function that calculates pressure. And our function has three variables. That's height. It has what was the other? Height, gravity, which is g equals to 9.8. So for the constants, you can actually declare them in the when you're defining the function, so that when you are recalling the function, you don't have to declare them all the time. So the other parameter that we need is density. Okay, density. Then we know that pressure, let's say P is equal to height times density. Height times density, then times gravity, gravitational pull. Then we shall return E. Okay, let's go ahead and recall our function. So to recall, you just have to say pressure. Then you put the variables. You can just write 100. Let's say the density is 1,000. Let's say G is 9.8. Okay. And it will calculate the pressure and it will return the answer. So to have it more organized, you can simply just write height equals to 100. Then you say density equals to that. And since you've already declared the gravity in the expression for the pressure, you don't have to declare it again. See what we get. We get exactly the same answer. So now let's look at if condition and how it's used. So here we have some examples. So we want to print this statement, which is x is positive, and this statement shall be written if x is positive. So our condition is if x is positive, so this will return a true statement since x is equal to 1, and it will go ahead and print x is positive. And there is another condition in this other example. So if x is not positive, what do you do? So you add another condition, which is else, and it will do something else. You print x is not positive. If it's not positive, it's negative. Then there is also another example here with a bit more conditions. So here we introduced and. If you remember from logics, we had this and statement. So if x is greater than 0 and y is greater than x, so here we have x is equal to 1 and y is equal to 3. So this will return a true statement. So it will go ahead and print this statement. But if not, so here you declare another condition with if x is equal to 0, 0. So x is not greater than 0, but it's equal to 0, 0. You print this statement. And if none of this is true, you just go ahead and print x is not positive. Okay. So let's go to a code and see how we can do this. So if I wanted to print x is positive if x is really positive. So we begin by declaring x is equal to 1. Then we put our if statement, which is if x is greater than 0, print is positive, print x is positive. So this will return a true statement, and I forgot something. Okay, so this returns a true statement and it will print x if x is positive. So let's add another condition, which is else. So if else. Okay, so in this other statement, we are adding something. If else, like if x is equal to positive, if x is positive. So in this other statement, we're adding a condition. If x is not positive, we print x is not positive. So here we shall try to run it with x. Let's say x is equal to -1. So it went through this condition and returned a false. And since it was a false, and we declared that it has to be positive in the first condition, it went ahead and ran the second condition, which is x is not positive. Let's add more conditions by using elif. So in this statement, x is equal to -1, y is equal to 3. So this first equation is not satisfied because x is negative, and although y is greater, x is negative. Okay, and so it will skip this because x is not equal to 0, and else it will just mean x is not positive. Now here we shall move to loops. In case we want to create a loop that runs something repeatedly for a given number of times. So here I want to run a loop that runs from 5 to -5 with a step of 1. So this is how you declare it, and to go ahead and run like this. Let's do it in a code. So another way of making loops is by using the while condition. So for this example, we have x which is equal to 1, and this code is going to run. It's going to print x until when this condition here is satisfied, which is x is less than 5. So if x is less than 5, this code will continue running and you keep printing x until when x is greater than 5. So it's always important to add an ending condition, like, because this code will just keep running and eating up your memory if you forget to add an ending condition. So in this case, our x will keep on increasing, and when it reaches 5, the code will stop. So you can go ahead and show this in a code. So it did not print 1 because x is already equal to 2. So let's change this to this instead. So we first print, then we increase x by 1. So it printed 1, 2, 3, 4, and when x was equal to 5, it's no longer less than 5, so it stopped. So next we shall be looking at lists and tuples. So to declare a list, we just need to use this and brackets for tuples. So for tuples, it cannot be modified, while for a list, it can be modified. So let's go ahead and create a list and look at different things that we can do with a list. Okay, so let's go ahead and look at a list. So we have created a list using comprehension. So for E in range 1 to 11, we have created this list. So this kind of creation is called comprehension. I'll be looking at it later at the end of the video. Let's go ahead and look at indexing. So how do you index? So indexing is very easy. So let's say we want to extract the first element of the list, which is 1. So the index of 1 is 0. So in list, this first one is called 0. That will be its index. And if you want to call it out, you just have to put this parenthesis and you put 0. So this element will be equal to 1. So this is how you index. So in case we wanted to get the last element, we just have to use -1. So -1 will go and bring the last element, which is 10. And to get the second last element, which is 9, you just have to add list, then you put the double parenthesis, you put -2, and that's how you get the 9th, the second last element from the list using index. Then the other thing is slicing, because we wanted to slice, because now we wanted to get from the first element to the third element. How do you do that? Use slicing. So slicing is basically the same thing, but instead of just adding one number, you have to add a range, and the range is separated by these two double dots. So let's say you wanted to get from 0 to 3, you just have to put it there like that, then you run, and it will return the first three digits or the first three elements from the list. And let's say another way of doing this is by simply putting dots, and so it will run from the first up to the third element. Or in case you wanted to get from the third element onwards, you want to get all the elements that are above the third element. You just had to write third, then you have the double parenthesis and nothing on the right hand side, and then it will return everything from that element, which is 4, 5 up to 10. Okay, and then there is also skipping. So here we wanted to return elements while skipping one element each time. So here we skipped 2, we skipped 4, we skipped 6. So this is how you do it. You just have to put 2 dots, 2 double dots, and then 2. Then if we wanted to skip, but in an inverse way, this time starting from 10, and then skipping the second value, you just do it the same way, but instead of just writing 2, you add a -2, so it will start from the last value, then moving to the next one while skipping what was in between. So here we had a 9, here we had a 7. Okay, that's it for slicing and indexing for lists. Now let's look at methods. So lists have a wide range of methods. You can do so many things with them. So there is something like append. Because you wanted to add something to the list. Let's say you wanted to add X, you can use append. There is clear, copy, count, extend, index, insert, pop, remove, len for calculating the length of the list, sort. You can change the order in which the list is organized. And here is an example. So here I wanted to add two lists together. So there is a list 1 that goes from 1 to 10, and then another list that has boys and girls. And if you wanted to add list 2 to list 1, you just say list 1.extend list 2, and you get something like this. And this one is for sorting. So you had a list of boys and girls. So it's boys first, then girls. And you want to change the order. You want to arrange it from the highest to the lowest. So here we are considering the highest, which is the alphabetical order. So G is bigger than B. So you just say list2.sort, and it will rearrange it in reverse. If you wanted to arrange it in the other way around, you say reverse equals to false. So in the code, some of the methods, so we've looked at extend, which is basically adding a list into another list. So we have created another list, which is list 2, and we are extending it into list 1 by simply using this method extend. Then the other method is sort. So we've sorted list 2. We can also do looping in our lists this way. So for I in list 2, so this loop will go and run, or it will first run the first element, then the second element. So the first time it runs, it will be girls, and the second time it runs, it will be boys, and that's how this basically works. There is also another interesting method, which is emulate. So this one will get the index of the list, the index of each element. So here you need two variables, which is one to represent the index and one to represent the value. So each time it loops, it will get the index and also the value, and you can have them printed this way. So here we know that the first element was 1 and its index was 0, and that's exactly what we have here. Then the other thing is zip. So zip will also run two variables in two lists. So let's say you wanted to get an element of list 1 and an element of list 2. You want to loop them together. So here you can just declare two variables, which is A and B. And then each time it runs, this variable here will be taken from list 1, and this B will be taken from list 2. And that's what you're seeing here. So 1, 1, and 1, 2. So this was gotten from list 1, this was gotten from list 2. Okay. Okay, so we have looked at lists and tuples. So let's go ahead and look at dictionaries. So dictionaries can be declared by using this kind of parenthesis. So basically in a dictionary we have keys and values. So this is a key, which is animals, and then we put two dots and then we add values. So values can be added in a list, or you can just have them outside. That's when it's just one value. So from a dictionary, you can get values. So we have already declared our dictionary up here. And we just want to get values from the dictionary. So you just say dic1 dot values, and it will return all the values. So the values are this list, which is this list that contains trees, and this other list that contains animals. All right. Then you can also return keys by just saying dic.keys, and it will return all the keys in the dictionary. Then the other functions are like basic functions that you can run on a dictionary. We have len, which will basically return the size of the dictionary, and that's the size of the keys. So it will just return two because you have two keys in your dictionary. That's animals and plants. Okay, so we have seen how to declare a dictionary, how to pull out the values, how to pull out the keys, and how to run some functions such as um, the dic size, how to get the size of the dictionary. Okay, all right. Okay, and let's see the other part, which is adding content to a dictionary. So to add new content, it's as simple as just adding this new key this way. Then you just say equals to new value, and it will be added as this. So we have our dictionary here, and our new key, which is declared in this way, has been added, and the new value that's associated to this key has also been added. So that's how you add a new value to your dictionary. So the other stuff is like the other methods that you can do, like in case you wanted to get the animals out of your dictionary. So you just say dic1.get animals, and you will get all the animals out of your dictionary. And the other functions that you can run, you can also run loops using the for. But this time you have to declare two variables because one will run in the keys and another one will run in the values. So now this is the last part of comprehension. So we looked at this in lists, how to create a list using a loop. Here we're using for. So it's as simple as just saying I, so it will put I, but for this I in a range of 1 to 4. So it's going to do something like this, 1, 2, 3, 4. 1, 2, 3. So actually in when you are running for, it does not run up to the last digit. It will run up to the last digit minus 1. So here to run from 1 to 3. And in case you wanted it to go up to 4, you have to say from 1 to 5. Okay, and for dictionaries, it's basically the same thing. The difference is you have to declare the key and also the value. And after that, it's basically the same thing. So you say k dot v for k and v in emulate list 1. So remember this code emulated returns the index and also the value of list 1. So k will correspond to the index and 1 will correspond to the element or the value in list 1. And that's how you do comprehension in lists. So at the end, we are going to look at the basic functions of Python. There are not very many. So you have seen print already, like if you want to write something on your screen. ABS, which is turning negative or positive to absolute, which is positive. Then you can round off a decimal using this code, which is round. You can get the max out of a list or a tuple. You can get the minimum. You can get the length of a list. You can get the type. We've already tried this code. Then you can change variable, which is, let's say, an integer into a string using this. String, you can change a number into an integer using this code here, which is int. You can also input data into your code. You can ask the user to input data using this input function. So to do that, you just say x is equal to string input. So when you run this code, it will ask the user to enter a variable which will be affected into x. So that's how you put something into Python. So that's it for this video. Thanks very much for watching. Please, if you find this video interesting, please share with someone who might be interested. And thanks for watching, and see you in my other video.